summer vacation is about to come to an end, isn't it?
Yep.
When do you go back?
15th.
Which is a week from Tuesday.
Mm-hmm.
Okay. Well, let's make sure we cover at least one section on proofs before then. Only because it will be easier for you in the beginning of geometry class. The basics of geometry, the stuff you're going to have to remember for a long time after you take geometry, is the stuff that we're covering and that we have covered this summer. And that's the important part of geometry. You really need to know the important part. Why they start on proofs, I can't tell you, but I'll try to help you get through that part. It's not that tough. It just tends to be a little demoralizing for a lot of kids. And I don't want it to be that for you, because you have good math skills. You'll do fine in geometry as long as you can get past the proofs psychologically.
Okay.
All right. We ended up last week on this problem here, where we have basically two circles. This one's 60 miles in all directions, meaning it has a radius of 60 miles. And this one is an additional 40 miles in all directions. So this one has a radius of 100 miles. And it says, by how many square miles was the visibility increased? Well, this is pi r squared, so it's 3600 pi. This is pi r squared, so it's 10,000 pi. Notice you always have, when you square a number with a lot of zeros, you have the number of zeros times 2. Pi. Come here. Stop barking. So, you've increased it, even though you only increased the radius by 40, which isn't even doubling it, you increase the area by almost 3 times. So this is a good problem that illustrates how when you increase the radius of a circle or the side of a square, you do a lot more than increase it by the same percentage when you look at its area. Hold on a second. I need to. Okay. If an arc with a length of 12 pi, well, they're talking arcs, they're talking circles, is 3/4 of the circumference. Well, let's just put a little XY grid on there. 3/4 of the circumference would be from there to there, right?
Mm-hmm.
So they're talking this distance. The distance of the circumference of that circle is 12 pi. Excuse me, the distance of 3/4 of the circumference of that circle is 12 pi. What is the total circumference of that? Remember that whenever you're dealing with problems with circles, you always have to find the radius. That's just, circles are defined by their radiuses. The radiuses tell all. It tells you what the area is, it tells you what the circumference is, it tells you everything you need to know about a circle is the radius. So, before we can find the radius, we have to find the full circumference. What's the total circumference? If 3/4 of the circumference,
16.
Yeah, if 3/4 of the circumference was equal to 12, multiply both sides by 4/3, and I get C equals 16. What's the formula for the circumference of a circle? Area is pi r squared. What is circumference?
2 pi r.
Yep. Same three numbers, just in a different sequence. And they're telling us our circumference is 16 pi. So solve for r. What is r?
14 pi.
How do you solve for it? When the 2 pi is multiplying the variable.
Oh, divide by.
Okay. You always do the opposite. You don't always subtract or add or multiply or divide. It depends on what that coefficient is doing. So what's 16 pi divided by 2 pi?
8 pi.
8.
Oh, just 8.
Just 8. Here, let's do it.
Oh, yeah, because they're divided by 5.
Yeah, the pi's cancel. So both of those cancel with that, and I get r equals 16 divided by 2. So that's the radius. But we're in the advanced section, so there's no way that that's what they're asking for. That's just the first step. But let's draw the circle. And they say we're talking about that arc where that's 90 degrees, right? In other words, if this arc is 3/4 of a circle, then this must be 90 degrees. And this is 8, and that's 8. In other words, we figured out the radius to be 8. So now they're asking, what is that distance? Well, this becomes a typical geometry problem where you're trying to solve this triangle. You have 8, 8, and they want to know what z is.
8.
What is it?
Well, it isn't yet.
It's a right triangle, so it follows Pythagorean Theorem. It's also an isosceles right triangle, which means this angle is equal to that angle, and since they're complementary, they have to be both 45. Well, trust me, every triangle you look at for the next 3 years is going to be either a 30-60-90 or a 45-45-90. So that's why I put so much effort into being able to solve for a third or even a second and third side for these two triangles. So what is z going to be? Now, let me put up the triangles that I draw more times than you can count. There's the 30-60. And always one opposite the side of the 30. And here's the 45-45. Also a right triangle, also one opposite the side of the 45. What's this side right here? Using the Pythagorean Theorem. What's the hypotenuse equal to?
2.
Square root of 2. Remember, your answer almost always begins with square root of when you are solving for a third side of a right triangle. Because the Pythagorean Theorem says that this squared plus that squared equals that squared. Well, this squared is 2. This squared is 1, that squared is 1, so 1 plus 1 is 2. So this has to be the square root of 2. So now, using the principle of similar triangles, these two triangles are similar because they have the same 3 angles.
The square root of 128.
Every side is proportional. What's the similarity ratio?
8 to 1.
Okay, so this has to be 8 times this.
Oh!
You got it now. I think you just clicked. I love it when I hear that from a student.
Square root of 2.
Oh, it means they just get it. What is it over here?
8 times the square root of 2.
That's your answer right there. All right, these are particularly tough. I don't know that it... Circles are important enough in geometry that even let's try the tough ones. Now, the one thing about geometry, when you run into a tough geometry problem, it just means you have to figure out all the other stuff before you can figure out what you're really looking for. Okay? So, let's figure out all the other stuff. What do they tell us? Excuse me. Well, yeah, there was another problem I forgot. But let's do this one as long as we're talking about it. And we'll go do the other one.
I don't know.
Well, let's take it step by step. The total area of the 4 equal circles is 36 pi. So what is the area of each circle, of the big circles?
9.
9 pi. Well, let's figure out radius. We're always looking for radius. 9 pi is equal to, what's the area formula? What's the area of a circle? Pi r squared.
Oh, pi r.
Tell you one way to remember that. Pi aren't squared. They're square. Or they're round, rather. If you go and look at any pi, it's round. So when you say pi r squared, it's different. It's an anomaly. It helps you remember it. Okay? So they're saying the area of each circle is 9 pi. And we know the area is pi r squared. So what's r?
3.
Okay. So now, let's draw some lines on this figure. And what do we know about the length of that line right there?
Double the radius.
Okay, so what is it? The radius is 3. Okay, so that one's 6. How about that one?
6.
That one is 6. And that one is 6. Okay? Now, they want basically the diameter of this small circle. So, we've got some geometry to do. Well, if I'm dealing with a square, if I can figure out that diagonal, well, I also know that all radiuses are equal, so that's 6 and that's 6. So if I took the length of that diagonal and subtracted it from 12, I would have the diameter of that small circle, right? Can you see that?
Yeah, I can see it.
Okay. So let's analyze everything but the circles here. Now, do you see why this is 6, the distance to the beginning of that circle? In other words, the distance from there to there is 6? Because all radiuses are equal. And the radius, excuse me, it's not 6. That's why you were confused. It's 3. That's the radius of that circle is 3. The distance of 2 radiuses was 6. So that's 3 and that's 3. All All right, so let's redraw this picture without the outside circles. We know that's 6, and that's 6. So can we figure out the distance? Let's call it z. Based on the problem we just had, if you take and draw a diagonal on a square, you end up with 45, 45.
6 times the square root of 2.
Exactly. So this is 6 square root of 2. And now we know that there's a circle in there of some diameter. And we know the distance from here to here is 3. And we know the distance from there to there is 3. So what's the diameter of that circle? Just based on this picture right there.
I have no clue.
Well, the total of the 3's is 6.
Because it's 6 times the square root of 2 minus 6.
So it is 6 minus 6 square root of 2. Excuse me. The diagonal of this triangle was 6 square root of 2, right?
Mm-hmm.
The whole thing. So if we take 6 square root of 2 and subtract out that part and that part, which is 6, that gives us everything else, the diameter of the rest of that line. So 6 square root of 2 minus 6 is the answer. Right?
Okay.
And that's as tough a geometry problem as you're going to run into all of next year.
All right.
There was a lot of things we had to do on that problem. But it's as good a geometry problem as you're going to run into also. Because it illustrated a whole bunch of things. It illustrated that all radiuses are equal. You had to know how to deal with a 45, 45, 90 right triangle. And you had to figure out this logic that you take the length of the total diagonal and you subtract off the 2 smaller pieces to get the diameter of this circle. All right, let's go to the next page. Oh no, let's go back and look at this other problem. This one right here. We've had a few problems like this before. We know that when there's a chord and you have a radius that's perpendicular to that chord, it bisects the chord. So the things we know are that AD is equal to DB. What else do we know? We know that OB is equal to OC because all radiuses are equal in the same circle. So that's going to answer everything we need to know about this, I believe. Let's see. AB has a length of 16. So each part of it is 8. And OB has a length of 10, which tells you the radius of that circle is 10.
Mm-hmm.
What is this distance right here? From here to here. Remember, that's a right triangle. What's your basic Pythagorean perfect triangle? What's your lowest perfect Pythagorean triangle?
3,
3, 4, 5. Is this a 3, 4, 5 triangle?
Yes.
Yes, always look for that. Because if you spot it, you don't have to go through the math of doing the Pythagorean Theorem. So what is the distance here?
6.
And if the distance from here to here is also 10,
Then that would be 4.
exactly.
The distance divided by 6.
You got it. That's the answer. All right. Maybe all of circles, which is fine because if it is, it'll give me 5 minutes to just. Yeah, the next section in this book is multiple figures. All kinds of figures. Let's not start that today.
All right.
Leave that for next week. And maybe not even next week. Let me give you a document that is going to help you with proofs, which will be the first thing you have to do. Unfortunately, they start off geometry with proofs, pretty much. So, and that's where everybody gets hung up. And then people get demoralized and they think geometry is impossibly difficult and they don't go forward. And yet you've seen that it's not impossibly difficult. It's actually pretty easy. You're doing fine in geometry. If geometry was all you had to do, you'd get an A in this class. You really would. If you can get through the proofs part, you'll probably still get an A. I think you have the math skills to get an A in your math classes. I really do. I don't know what's happened the last couple of years, but the skills I saw from you algebraically were strong. All right. In order to do proofs, you're going to have to memorize all of these 8 properties. And some of them are really strange. Let's just kind of go over them in the last 4 minutes. Don't try to memorize them all today. Try to understand them today. I'll bring this up again next week, and we'll have another look at it. But you're going to have access to this table in order to do proofs.
I just took a picture of it.
Okay. I'm sure you'll get it again in whatever book or computer website they give you. This won't be the first time you see it. The addition property merely says if A equals B and I add any number to A, then it's the same as adding it to B. In other words, if 3 equals 3, then 3 plus 2 equals 3 plus 2. That's all this is saying, the addition property. Subtraction property, just the opposite. Not even an additional property if you think about it. In other words, if A equals B, then A minus C equals B minus C. The multiplication property. Easy enough. If A equals B, then some number times A equals some number times B. It's at about this point in geometry where everybody starts saying, well, these are obvious. Why do we have to memorize these? I mean, look at the reflexive property. That's a property. If for any number A equals A, that's when you really go crazy, is when they give you this one. But there are some proofs where you have to use this property. You can't say that a number is equal to itself unless you reference the reflexive property. It's silly, but let's see. The division property is the same as the multiplication property, only the inverse of it. Okay? So we have the reflexive property. Remember that name. And that it merely means that something is equal to itself. these last four are the tough ones to memorize because they're so obvious. We've known them for so long that who wants to put a title on it? You know what I'm saying? The symmetric property merely means if A equals B, then B equals A. That's obvious. The transitive property means if A equals B and B equals something else, C, therefore, then A must be equal to C, right? Makes sense. Substitution property. If A equals B, then A can be substituted for B in any equation or expression that involves B. In other words, if A equals B and B equals 3C plus 7, then A equals 3C plus 7. That's all these properties do. But these 8 properties that nobody wants to memorize, that give everybody all the problems and proofs. You need to memorize these 8 properties. That's all I can say, and that is your best first step for dealing with proofs when you get to them.
Okay.
Okay? So we'll leave it at that, and maybe next time I talk to you, I'll quiz you a little bit on these 8 properties. Best favor you could do for yourself between now and next week is memorize these 8 properties.
All right.
Okay? All right, Cole, I will talk to you next Monday.
Talk to you then.
Okay?